This video is a continuation of our video series where we are choosing a stock portfolio. Last video we left off with, we had cleaned our data and we had invoked these three constraints on our original data set. And we were left with a market of firms, 2,629 firms to be exact. Each firm in this data set has 36 prior monthly return numbers. There's a monthly return for January of 2010, February of 2010, all the way through December of 2012 for each firm. So for each company ID in this data set, there are 36 rows. 2,629 company IDs times 36 rows, and that's where you get the 94,644 rows. All right, it's time to choose our portfolio from this market. We're going to pick a 250 firm portfolio, and I won't go into why the size is going to be 250, but assume that's the size you want to pick. And it's time to invoke the algorithm. So essentially, in short, what this algorithm will do is it will ensure that the 250 firms we pick out of this market have very relatively low correlation with each other in terms of their 36 returns, prior returns. If you look at this 250 firms that we pick from this market, we're going to pick these 250 in such a way that each pair of firms in the 250 has relatively low correlation with each other. So the average pairwise correlation, firm 1 and 2, firm 1 and 3, firm 1 and 250, firm 2 and 1, firm 2 and 3, firm 2 and 4, firm 2 and 250. If we calculate the average of all those pairwise correlations, we're going to get a relatively small number. Relatively small versus if we bought the whole market, all 2,629 firms, and we calculate the average of the average pairwise correlation in the prior 36 months of returns for that market, it would be a bigger number. So the idea is we're trying to pick a group of firms such that if one of the firms does poorly going forward, that hopefully the other firms won't do poorly as well. We're trying to minimize our risk, right? And so the algorithm is all about minimizing risk, and it's not really anything about maximizing returns, as you see here. And then we'll see how the portfolio performs in 2013. But the idea is we're trying to minimize our risk, but we don't want to buy the whole market. So what I've shown in my paper, and you could look at the paper if you wanted to, in my research paper, but the risk of holding this smaller portfolio is actually smaller than holding the whole market, which seems counterintuitive, but it's actually true. You take on less risk by judiciously choosing this 250 firms and holding that portfolio than you would if you took and owned all 2,629 firms. Also, it costs less to buy 250 than it does to buy 2,629. It's easier to do as an investor. But we're getting outside of the scope of this case here. All I want to do is show you how to do this in Alteryx. So the first part of the algorithm is to find the correlation matrix. So we want the correlation between firm 1's 36 returns and firm 2's 36 returns. Firm 1 and firm 3, firm 1 and firm 4, firm 2 and firm 3, firm 2 and 4. All the possible pairwise correlations. So this correlation matrix will be 2,629 rows by 2,629 columns. There's a lot of correlations there. 6 million, over 6 million to be exact, total correlations, pairwise correlations. To calculate this correlation matrix, we're going to use the Pearson correlation tool in Alteryx. But before you can use the Pearson correlation tool, your data has to be in a certain format. The first thing we can do is get rid of date, SIC industry, and ticker as variables. All we were concerned about with the algorithm is the return, and of course we need the company ID. So let's grab a select tool. Let's get rid of date, industry ticker. Let's run this. We just have our two variables, company ID and monthly return. We can't attach a Pearson correlation tool to the data in this format. What we need, instead of the returns being stacked on top of each other, as we currently have, right? We have firm 1 or firm 10001 and its 36 numbers, and then we have firm 100025, I believe, is the next one, and then its 36 numbers. Yeah. And then we have firm 3, or whatever the company ID is, and its 36, and firm 4. They're all stacked on top of each other. We don't want that. We want firm 1's 36 numbers to be in the first column, firm 2's 36 numbers to be in the second column, and so forth. We want our data in that format, and then we can use the Pearson correlation tool, because the Pearson correlation tool assumes that your data is in that format before it starts calculating things. All right, so what we can do, we want to get this data in the format I described. So first thing you should do, you would think, let's just attach a crosstab tool. That'll change it into columns, right? We'll group data by company ID. The new columns will be the company ID, company 1, then company 2, company 3. The values for the new columns will be the monthly returns, but then the problem is we got to choose a method for aggregating values. And no matter what method we choose, we don't want to sum up the 36 numbers. We want all 36 numbers to be in each column for each firm. Not the sum of the 36, not the average of the 36. So this isn't going to give us what we want. The reason is that if we choose sum, it's going to sum the 36 numbers as long as the company ID is the same. For example, I'll show you what it looks like if we just did crosstab. And you'll see it's not what we want. So we almost have what we want. We have the company IDs here, firm 1, firm 2, firm 3, firm 4. But we don't have what we want. Firm 1's column, we want it to be a column of 36 rows, and it has the 36 prior monthly returns, not the sum of the 36 prior monthly returns. So I played with this for a while, and I realized you can't do a crosstab tool first. The way you do it is you use a make columns tool. Well, there's different ways to do this. You could also use, trying to think, you can use a, there are different ways to do what I'm going to do, as usual in Alteryx. But this is the way that works. So if you attach a make columns tool, and I haven't shown this, I haven't gone over the make columns tool in a previous video, I don't believe, or maybe I did. I can't remember. But we want 36 columns. We'll arrange horizontally, and we'll group by company ID. So this transforms our data to look like this. Now we have firm 1's 36 numbers in row 1, firm 2's 36 numbers in row 2, firm 3's 36 numbers in row 3. Not quite what we want, but the key is, you see the column headers? We have this new variable here. And it takes on, and you'll see here, this new variable, column 1 monthly return, column 2 monthly return. When we do the crosstab, not crosstab, I'm sorry, when we do transpose now, we want our key columns to be company ID and our data columns to be the 36 columns there, and we hit run. You see we have this, which looks like what we had before, except now it's just exactly what we had when we started. But now we have this other column, and it changes. So column 1 monthly return, column 2 monthly return, column 3 monthly return, all the way to column 36 monthly return. And then it starts over for the next firm, column 1 monthly return, column 2 monthly return, and so forth. The key thing is now we can use our crosstab tool because these change. I mean, this is a different name than this is. This is a different name than this is. And we can group by this variable, by the name variable. And we can, when we aggregate, you'll see that it won't. For example, because for as long as the company ID is the same, there's only one column 1 monthly return. It's this number. So when we use the crosstab tool, we can choose, as a method of aggregation, we could choose average or sum. The sum of this number with itself is just this number. Same thing with the average. It's just this number. And then the crosstab will look at the next one. Oh, this one. The problem before with crosstab was it'll say, oh, this and this are the same thing. So we need to sum these two together. As long as they're the same thing, it just sums by this. But now we have this other variable which changes. And it's not going to sum column 1 monthly return for firm 1 with column 1 monthly return for firm 2 because firm 2 and firm 1 are different. So we don't have to worry about that. So crosstab, group data by name. Our new column headers will be the company IDs. Our values for the new column will be the monthly returns, but it's changed their name to value. If you look here, you see now it calls it value. And method of aggregation, we can choose either sum or average. It doesn't matter. We don't want to choose count because then the count will just be 1. For firm 1, there's only one column 1 monthly return. There's only one first month's return and so forth. Now we hit run. We look at our output here. All right. Now not everything is displayed here, but we have the firm IDs here. Here's firm 1's 36 monthly returns, but it put month 10 monthly return first, then month 11. It gets them out of order, but all 36 are there. You see it only displayed 25 of 36 records, but if you keep going down, they're all there. We just have to sort this by this column in dictionary order to get them in the right order. So sort by the name column in ascending order and use dictionary order. And now we are left with, if it will let me choose it, here we go, 36 numbers. And then we just need to check, is that month 1's return for this firm, negative 0.0189. Let's go back to our original, negative 0.0189. Let's pick another month, like month 14. We should find 0.022727. Just check and make sure it's doing what we expected it would do. Month 14, 0.022727. So it seems like it got it. So now we have exactly what I had said. All we need to do now is get rid of this column, and we have our data in the format that we can use the Pearson correlation tool on. So let's get rid of, use the select tool. We only want to keep these columns, and we don't want that first column. And now, if we view our data here, it's in the format that I described that we needed to get it in so that we could use the Pearson correlation tool. Each firm has its column, and column 1 is the 36 prior monthly returns for this firm. Column 2 is the 36 prior monthly returns for this firm. This is the January 2010 return for this firm. This is the January 2010 return for this firm, and so forth. This is the February 2010 return for this firm, February for this firm, February for this firm. Now when we use the Pearson correlation tool, it's going to calculate the correlation between firm 1's 36 numbers and firm 2's 36 numbers, firm 1 and firm 3, firm 1 and firm 4. For each firm, it's going to calculate the correlation between that firm's 36 numbers and all the other firms' 36 numbers. And the output is going to be a matrix, a square matrix. The number of firms is 2,629, and so the Pearson correlation matrix is going to be 2,629 by 2,629. Let's do it. Pearson correlation tool. Generate correlation for selected variables. All. Calculate correlation, not covariance. Hit run. Does it so fast. Here's the output. Obviously, not all records are displayed, not all rows are displayed, but row 1, correlation between firm 1 and itself in terms of the 36 prior returns is 100%. 1. The correlation between a variable and itself is 1. Correlation between firm 1's 36 prior returns and firm 2's 36 prior returns is 0.295467, and the value is rounded to 6 decimal places for clarity. That's what these red things mean. And so here's our square correlation matrix. As you can imagine, the upper triangular portion of it, in other words, the triangular portion above the diagonal is all 1s. The triangular portion above the diagonal is a mirror image of the triangular portion below the diagonal, right? Correlation between firm 1 and firm 2 is 0.295467. The correlation between firm 2 and firm 1 is 0.295467, right? The correlation between of x and y is the same as the correlation between y and x. That's the property of correlation. So now we have these correlations. Now we can invoke the algorithm on this matrix. So here's the algorithm. So once we form this correlation matrix, we will analyze it to form our 250 firm portfolio. So first find the firm most correlated with each firm. That is, find the max correlation value for each row, excluding the correlation of each firm with itself, which is 1. So if we go back and look at our matrix here, our correlation matrix, here's the first row. This row represents the correlation between firm 1's 36 prior monthly returns, and all the other firms, including firm 1's 36 prior monthly returns. What's the max value in this row? Not counting this 1, because obviously that's going to be the biggest value. Correlation is bounded above by 1, can't be bigger than 1, and bounded below by -1, can't be lower than -1. So all the numbers in this row are between -1 and +1 inclusive of negative and +1. So what's the max value in this row, not counting this number, not counting the correlation between the firm and itself? That's what we want to find for each row. So that's the first part of the algorithm. All right, how are we going to go about doing that? Well, let's transpose our data. Key columns will be the field name. Data columns will be everything else. Hit run. So this gets our matrix, turns our matrix into this. So field name, here's the first firm. Then we have our name column. And then we have our correlation. So correlation between firm 1 and itself is 1. Correlation between firm 1 and the next firm, there it is. Firm 1 and the third firm, there it is, and so forth. So you can see the first 2,629 rows will be the correlation between firm 1 and all the firms, including itself. The next 2,629 rows will be the correlation between firm 2 and all the firms, and so forth. There should be this many rows. The number of rows here should be exactly the same as the number of entries in the Pearson correlation matrix. The total number of entries. There's entry 1, 2, 3, all the way over to 2,629. There's entry 2,630, 2,631. And so 2,629 times 2,629, that's how many entries there are. So that should be the number of rows of our transpose. And if you multiply 2629 by itself, you get 6,911,641. So you should do these calculations in your head, or on your, not in your head, but on the calculator, just to check to make sure that everything is okay. Now that we have the data in this format, we're able to find for each firm the max value, the max correlation, not counting the 1. So the first thing we need to do is get rid of, we can use a filter tool and get rid of all rows where the value is equal to 1. That gets rid of all those correlations of the firm with itself. So grab a filter tool. Well, where did it go? Put it right here. Grab this filter tool. We're going to filter value equal 1 is fine. So the rows where the value equals 1 will go to the true, and the rows where the value does not equal 1 will go to the false. We want the false. And we could verify our total number of rows now should be what it was before, minus 2,629. We should have lost 2,629 because if you think about the diagonal of the Pearson correlation matrix, how many entries are on the diagonal? 2,629. All right. Now we can use a summarize tool and we can group by the field name, and we can also, for the value variable, we can find the max. And we run the workflow. It's starting to take a while now because we have a lot of data here. All right. For each unique field name, this is the max correlation. So some firm has here's firm 10001. The firm most correlated with this firm has a correlation with this firm of 0.694. Now, we don't know what firm that is from doing this. We just know that's the max correlation value. We could go find which firm that was, but we don't have to yet. So we've done the first part here. We've gotten the correlation matrix, and we found the max correlation value for each row. So now what we need to do, it says here, keep track of both the correlation value and the firm most correlated with each firm. We don't have to actually do that, so that's not true. Just keep track of the correlation value. Should change that. And I should also change this here. When you see this document, I will have already made this change as I'm doing here, and so you won't, when you read it, it'll have what I made here. First, find the max correlation value for each row. All right, so this is right. All right, now we can sort this. Grab a sort tool. I'll put it up here, I guess. And I gotta sneeze. Excuse me. And we'll sort. Go back and look at our data here. Yikes, what happened? What did I do? Tabbed document. Here's our data. We're going to sort by the max value. I've put, there we go. So we're going to sort by the max value here in ascending order. And we're going to grab the first 250 firms. All right. So this firm, the max correlation that any other firm had with this firm was this. So that means all other firms prior 36 monthly returns, when we calculated the correlation between any of those other firms with this firm's 36 prior monthly returns, we got a correlation value that was less than or equal to this. So we've sorted. And our portfolio is going to be the first 250 here. As opposed to, look here at the bottom. This firm. There was a firm that was correlated with this firm, almost 1. And any other firm, as compared to this firm, any other firm, the correlation between any other firm and this firm is less than or equal to this, which is kind of a high value. So by doing this algorithm, if we keep these first 250, we're assured that we have firms that have a relatively low correlation with the rest of the market, with the rest of the firms in the market, including each other. So that's the algorithm, and I've shown in my research that there's a lot of implications of doing this. I've done all sorts of statistics over the last 65 years. I'm not going to go into all that. You could read the paper. But choosing these first 250 ensures that you have a portfolio with relatively low risk, and we're going to look at the performance of that portfolio out of sample, that is in 2013. Because as of the beginning of 2013, we're just using data we have available at that time, which would be data between 2010 and 2012, according to our algorithm. And so we're not like cheating. We don't know what's going to happen in 2030. We're choosing these firms as of what we would have known as of January 2013. We would have known all this. We would have had this data set, and we would have run this algorithm. You could have actually picked these firms and then held them in 2013 and see how you did. I've actually done this algorithm myself with my own money and bought the 250 firms that the algorithm said to buy. I did it in 4 straight years, and it performed very well. It performed exactly as my results, all my backtesting results, suggested that it would. So now we just want to grab the first 250, and that's pretty easy. We just we can grab a sample tool. So different ways to do this, but one way is just grab the sample tool, grab the first n rows, n equals 250. We'll run this. And here are the firms that we're going to, here are the their ID numbers, the firms that we're going to buy, that we're going to hold in our portfolio. All we need are the ID numbers. Now we can go find the tickers for these firms by going back and joining this with our original starting data set, by joining it with the data set before we remove those three variables right here. All those company IDs, those 250 company IDs, they're in here, and we can go find their tickers so that we know which companies to buy when we actually go purchase them. But because the company identification that's used whenever you use one of these trading platforms like Charles Schwab, or there's a bunch of them, it always wants you to input the ticker. All right, not the company ID variable. So there's our portfolio, and then we can sort. We can do another sort tool and just sort it by field name in ascending order. It just sorts it by that company ID variable, which is, through all these iterations, has been renamed a field name, but that's okay. This is our company ID. So we've just sorted, we have this, what we just had, we've sorted it by company ID. All right. So that concludes this video. In the next video, we're going to look at our portfolio here, these companies, and we're going to look at which industries they're in. What's our industry membership? SIC industry membership. So we're going to have to go back and join that with our data set here so we can find the industry that the firm is in. And then also we're going to use the SIC industry file that I sent you, which has, for each code, it has the actual industry. It tells what it is, like food or dairy, things of that nature, forestry products. And so we can see our 250 firms that we're going to hold as our portfolio. Are they all in the same industry? My guess is they're not. Otherwise, we wouldn't have these low correlation values, right? Returns for firms in the same industry, the prior 36 months returns for two firms in the same industry likely are more highly correlated than firms that are in different industries, right? Because there's some common thing that affects the industry. It's going to affect both firms similarly. So my guess is because our algorithm is based on minimizing these pairwise correlations, we're probably going to have a nice spread of industries within our 250 firms. In other words, we're going to represent lots of the different industries, not just all in one industry. So that concludes this video.